Warsaw JS.
Hello, we are live, and that's the Warsaw JS 77th meetup. Yay! So we start, and there is my short intro in the beginning, and after that, we're going to start with the first talk. So today, the Warsaw JS Meetup organizing team consists of me, Ania Dławichowska, Maciek Machniewski, Luisa Buta, Mirek Stasiak, and Łukasz Basaj. All of us are directly involved in this event. However, there are a lot of other people helping us to make it happen. So what is Warsaw JS and why are we here? So besides we just organize the meetups where you can learn knowledge for free, besides we also create a community. For everyone, we create a space where people meet and they can learn from each other and teach others what they know. So that's our main idea, the lifetime knowledge sharing and learning. And we also offer an environment of respect and support. And to make it happen, we also follow the code of conduct. You can go there and see what exactly consists the code of conduct, but mainly this is about non-violence and respect to all the other people and their specificity. So what can I say? Today we looked at Meetup and we are over 5,640 people there. So we are very happy to see that the community is growing. And if you're still not on Meetup with us, go to meetup.com/WarsawJS. To get more in touch with us, you can also go to warsawjs.com, and there you can find a link to Slack, to WarsawJS Slack. And when you go to WarsawJS Slack, you can talk directly with all of us or indirectly through channels, which are usually oriented to certain technology, like Vue.js channel, Angular channel, React channel, and so on, and other help channels where you can also learn something more specific in certain technology. So the sponsors of today are 10 Clouds, Fresha, Prisma, Xfang, Daft Code, PackHelp, and Sumo Logic. Thanks to them, we have all the means for to creating this event, to create this event. We also have a partner, it's JetBrains, and we have some licenses from them for the community. If you want to have a license, just join us on Remo. Remo is the place for the online event where you can live talk at a table with other participants of the event. And there at Remo, you can get this license just for free. It's a 1-year subscription. Just ping me when you get there. For the first 2 people who ping me on Remo, I'm going to give the licenses. So this is how Remo looks like. I'm somewhere here. You can find me and ping me. And yeah, and what's more? Yeah, we have a special day today because we want to offer you the Warsaw JS chess set. Warsaw JS chess set become very famous after Natalia from Prisma shared this tweet that she got it as a Christmas gift. And there are a lot of you who are interested in getting this similar gift. So we decided to make an auction to one of the most famous Polish charity events ever. That is the 27th final of, or 29th actually, this year, final of this charity organization. And you can beat the price of it. We start with 42 zlotys for that set. And yeah, the guy who pays the most or girl will get this chess set. Okay, so one more very important thing. We have Warsaw JS workshop on the 13th. No, not on the 13th of December. On next Sunday. So that's, I guess, 17th of January. And on 17th of January we have this workshop with these people, and it's for beginners, so you can learn JavaScript from beginning if you want. Okay, so the speakers for today. The first speaker will be David Williams or Bartek Bilejczyk. I need to check for a moment because David said this. Okay, David is even here. All right, so we start with David. David will tell us about the birth and the future of the World Wide Web. Later, Bartek Bilejczyk about white labeling your product using SASS and JS. And Guillaume Chevalier, the business process of machine learning from Canada. Okay, so we start with David today. David, are you here? Can you hear me?
I can hear you. How are you doing?
Thank you. I'm doing great. Although you're on the other side of the ocean, we still can hear you very well, and we can.
Welcome to sunny California. You can see it's nice and bright and sunny out right now.
Awesome. David, just to introduce you, you happen to be the similar team at the same place when the World Wide Web was created, and actually that's shocking because you're actually a particle physicist. Besides, you also are a programmer, and also you actually also create music. So I don't know how you joined all of this. It's really incredible.
I mean, I was a particle physicist. It's my degree from MIT. And I was actually there at MIT where some events happened. And I actually watched the growth of the web. You know, most of the big explosion was when I was actually living in Hamburg, Germany, at the DAISY laboratory, where I actually met a lot of your compatriot. Poland of course, has a very prestigious physics history, right? And then later on, as I got tired of the academic race, I joined a private company called Version and continued programming in the molecular modeling space, where I currently sit. And in that process, I developed a lot of the web technology used at the company, including the laboratory information system. I'll just talk briefly about that. And I want to give a perspective about, you know, what the web means to me, how I grew up with it, and what this maybe tells people about what might be coming next in terms of innovation.
David, I'm really honored to be your host today, and so let's start, and let's check if your presentation is up and running.
Let's see. So I have to share my screen. Okay, share screen. All right. Hopefully you can see this.
Yes, it's there. Okay.
All right.
So then,
here's the title. So
the next 25 minutes are for you, and the plan is that later, just after your presentation, you can join us on Remo and have a short questions and answers session at the table with 7 other participants from Warsaw JS. So good luck, David, and I'll be back after you finish with the presentation.
My pleasure. So here I'm showing a picture of a particle physics experiment. And so, you know, why am I doing this? Well, part of the reason is there's some history here. This is the End Station A experiment at SLAC. And this experiment actually discovered quarks. It won Nobel Prize in 1990. And 2 members of the Nobel Prize in 1990 were physicists at MIT, were my mentors in my group. And they were able to tell me stories about how this experiment worked. You know, I wasn't actually involved in that, but they told me about things they were doing back then with computers, which was really very fascinating. And the reason why, you know, you might ask yourself, why was the World Wide Web invented in high-energy physics? And the reason why is that in high-energy physics, you're dealing with some very difficult concepts like data acquisition. I mean, the idea of connecting computers to instrumentation was something that was invented in physics. Numerical analysis, of course, and most importantly, international collaborations. In high-energy physics, collaborations typically span the world, and there's a problem, of course, of communication. Now, this is the counting house for End Station A. And I want to show you this because it's kind of funny. You look at these instruments on this rack. There are these counters, and there's actually these little tubes. They're called mixer tubes, I think. And what they used to do in the old days before computers is they would actually read these numbers off a rack and write them in a logbook by hand. And when they published a paper, they would, do the calculations by hand with actually hand calculators and draw the graphs with rulers, and that's how they published papers. Now, obviously, this is not very efficient compared to our standards. And so there was a lot of work in trying to automate this, right? Now, the other thing, too, is remember documentation. I mean, these days, if you want to know how something works or get an API, you simply just look it up in the web. In the old days, of course, there was no internet. And so we used to, and I remember this because I worked at this time, we used to have these hard copies of documents. This orange shelf of bookcase is actually the VMS documentation. And I was very fortunate to have the shelf in my office. So when I needed to look up something to implement something in a VAX, I can turn around and open up a book. And I would actually do this. Other cases, we would sometimes have copies of documentations on a mainframe, and you go to the central printing facility because you didn't have your own printer. And if if you knew how, you can print out the documentation on this little green paper. And we would have these green paper documents on our desks, to look up things like CernLight. In this case, this is a prettier PDF version. So, obviously it's kind of inefficient. I'm working on a project. I want to use a numerical library. I have to open up a book or, find a document. Maybe you have to get up, and go to the library, for example, and look up something. That's not very efficient. So now, documentation on demand. So one thing, the first time I used the World Wide Web, and I didn't, of course, realize what I was using, is because I wanted to look up documentation on libraries. And I discovered, someone told me about this beautiful thing from CERN where you can actually log in or actually just connect, and you get these little links. You can see little links with numbers, and you can actually look up all the documentations on CERN's computational library. CERN is, of course, a laboratory in the border of Switzerland and France, which does high-energy physics. I actually did this on a IBM mainframe, and it looked like this. It was green, 40 by 80 characters. And what am I talking about? Yes, literally, this was the computer. And at Stanford at that time, we had an IBM 360 mainframe to do computational work. And the terminals were connected with serial cables. They actually ran serial cables all through the buildings. And if you're fortunate, you had one of these nice terminals on your desk where you actually programmed. The IBM 360 mainframe at Stanford was used up to 1998. So yeah, so this was my use of the World Wide Web when it first came out. And this is actually pre-internet, believe it or not. Speaking of which, internet. Another thing that high-energy physics is dealt with, and also energy physics and the Department of Defense in the US, was the internet system, was the what we called HEPnet or HEPnet. And this is a picture from 40th anniversary of what's called National Network in the United States, and you can see these. You can see this caption is kind of hard to read. Dual 56 kilobyte, and you can see the laboratories. So I was here at MIT. I spent some time also at Fermilab. Here's Fermilab, and of course I spent time here at SLAC. And so these are the major hubs. And as an undergraduate, I worked at MIT, and it was quite amusing because we had this beautiful 5600 kilobyte connection to Fermilab. And what MIT actually did is they rented satellite time to get this connection. It was fabulously expensive. Okay, so this is people at Stanford. So obviously, using mainframes is not something that everyone can do at home. And soon after, graphical systems started coming up. And this is actually the Midas browser, which was developed by this person here, Tony Johnson, who actually sat in my desk, sat about 3 offices down in the hallway, because 2 of us worked on the same experiment called SLD. Also in this picture is Paul Kunz. Paul Kunz was famous for locking his door and smoking his pipe like crazy, which I'm not sure was even allowed back then. And he was a big proponent. You can see he's sitting in front of a Next computer. I don't know if you guys recognize the Next computer. That's what it actually looked like. And this is back when it first came out. You can actually go in the Stanford campus and buy one of these machines. It was like ridiculously expensive, more expensive than the car. And over here is the head librarian, which actually was the boss of my wife, who was working at the library at that time. So, and this is what the browser looked like. No one's heard of this. I used it for briefly, but soon after this browser was developed, Mosaic took over, and that was the end of it. By the way, this is Motif, which is an X Window standard, predecessor of sort of the modern window managers you see in Linux these days. So this is actually my personal webpage. I was looking at ones that are older, but they're too old even for the Wayback Machine. This is one that's dated September 2000. And back then, these are actually handmade. And this is not really necessary. It was kind of a fun thing to do, as a way of communicating yourself to other people in the high energy physics community, which is basically what this is for. You do notice that I did teach a class in high energy physics at Santa Cruz, and actually I had a link here for those students to get, I guess, problem sets, because back then all classes were taught on whiteboards. We didn't use presentations for that. And this is a picture of me, which is really grainy, actually at End Station A. This is End Station A behind it at Stanford. And it's a really, really crappy picture, because back then you don't just dump 1 megabyte pictures on the web, because people were phoning in with their 56K baud modems. You didn't do that. So this was extremely compressed to it's almost unrecognizable. And this is me when I was a lot younger, and this is my dosimeter, because this is a radiation area. Everyone in that point in high energy physics was basically using X Windows thin clients connected to Linux, to Unix mainframes. Only later did we start moving to Linux workstations, which we mostly used actually as thin clients to log into the big machines we had access to. This is actually, yes. So I actually reconstructed this from the Wayback Machine, and this is my code I wrote by hand, and I give all these like friendly comments like, yeah, where do these reptiles come from? This is kind of cute reptile background, and I talk about where it came from. Someone at Caltech made it. I have no idea who this person is. And I talk about how to make my name, right? This cool text. And it's kind of funny, this cooltext.com still exists. It's a little bit quaint. You can try it if you want. And I talk about how I make the background transparent, because of course it would come with a white background. And I'm making fun of Windows. Anyway, and some other comments about making things line up. So it's kind of cute to look at this thinking, I of course don't remember when I actually wrote this. A couple of things about this, you notice that everything is HTML, there's no CSS. CSS came a little bit later. It was mostly available, but most of us didn't know how to use it. Everything is specified explicitly, like the width and height. Here I was very good about putting alternate text. And that was sort of important because there were still people using text browsers at that point. And yes, here's my link page. And most people had link pages because we didn't have Google. So to find things actually was a bit of a challenge. This is Alta Vista. Some of you may have heard of this. This is the old Yahoo, which was categories. And Yahoo with categories actually had people going through and making explicit categories in a category tree, believe it or not. This is an animated GIF. It's not animated here because this is a screenshot. So let's move ahead 7 years. And this is where I left high energy physics and joined a company and started working on web technology in a commercial setting. This is for internal tools. And I actually looked this up. Turns out we have our Subversion repository going back almost 15 years. Here's a deposit I made 13 years ago. And this is written in Perl. It's a Perl CGI script. This was extremely common back then, where you simply had Apache that would execute a shell script, and the output of your shell script, see the print statements, is the web page. And this is horrifyingly bad code because you notice I'm taking a parameter directly and inserting in HTML, which is like a giant big no-no with no escaping. So it's kind of funny. And also some of this is just bad, a mixture of code that's templated and code that's explicit. So anyway, but I actually knew Perl as a high energy physicist. I didn't really use Python, so this was a natural thing for me to start with. But later on, oh yeah, I should mention what's this thing with CGI? People must know about CGI, but it was the way to do things back then, executables. And you can actually still find in the Apache documentation these horrible things where you can allow people in their home directories to actually have CGI scripts. And in the old days, they would be executed by root. And so you actually had a situation where you allow users to insert scripts in their home directories, which can be executed by root when they're visited by someone's web browser, which is like horrific security violation. And this was actually quite common. Unix was never a very good secure operating system. This book, by the way, the Unix Haters Handbook, is now publicly available. If you're interested in a little bit of history and a little bit of a laugh, I suggest you take a look at this link and find this book. It's really very funny, and you will learn, for example, why, and if you look at the raw text of your mail messages sometimes have these strange symbols inserted. It's really very amusing. Anyway, later on, I switched to Python, and this is like better CGI. It's still a CGI. It's still shell encrypted, scripted, except now we moved to mod CGI. So the Python interpreter was embedded in Apache, so you avoid the startup costs. And here you can see I'm still using templates for HTML that's actually in the code. And this is something I like doing because I really did not like external templates, because I wanted the code you're using to be connected to what you're actually seeing on the screen. Later on, I learned that my system design for this page is actually something called Roca, which means it's basically very, very RESTful, very, very simple, and very elegant. And this actually suits this application very well, which is a laboratory information system. And it's still in basic use today. Although recently, around 2016, I did migrate to central routing. You can see this pyramid scheme. Still separate scripts, but at least now in a real framework, and moved to Python 3, moved to Pyramid, and ultimately it's now deployed using Dockerized, using GUnicorn, using proxies, and a very modern deployment. This is what one of the pages actually looks like, if you're curious. Now, by the way, this is developed in Linux. For the longest time, I've been looking for a decent code editor, and it only recently did I actually find one I finally liked, which is Visual Studio Code, which brings up the question about when Microsoft finally actually became cool. Visual Studio Code, of course, is written in Electron, which is actually JavaScript. And then finally, also, we actually developed new tools. This tool is for the clients of our company, the laboratory people. This is an internal research tool. And for this, we just started from scratch using all the modern tools. And this is where I learned about React, Redux, Webpack, and the back end of this is a Flask API and Python. And so one thing I want to mention about React is, again, HTML integration, because you have HTML actually written in your script. And one thing about Webpacks I really loved is that I can finally put comments in my JavaScript. Because for those of you worried about performance, you don't usually put extraneous things in your JavaScript because it gets served. In this case, you're welcome to put all nice comments. In this case, this code is so well written and you don't really need many comments. This is kind of nice. I really fell in love with JSX because basically you're building the HTML page in your actual code. Just a little bit about this, a little bit about software engineering and coupling. So the one thing that really annoys me about these templates is you have code that accesses template file in a separate place, oftentimes a very separate directory. And me, this is annoys my sensibilities. This is why JSX is really nice, because you're actually doing the HTML all properly constructed and escaped actually in the code. And to me, this is a huge, huge win for maintainability and reliability. And you start asking yourself, why was CGI so successful? It's because it's very much like this. Why was PHP successful? PHP is a horrible language. It became successful because it's the web page that you're actually coding in. And it's not, I don't think, an accident. And you ask yourself, why did JSX do this? I think this is actually very, very deliberate and actually very smart. Software engineering number 2, I call this referential transparency. Basically, you have stateful objects. So you update a React component, you alter a property, which means you alter its state. This is actually a pretty severe limitation on how you write code. And the question is, why did they do that? They did it for a very good reason. It's the idea of state. State being very important. And I think in particular, when we talk about JavaScript, the fact that JavaScript runs asynchronously is a source of a lot of confusion, especially for junior programmers. And if you reduce the asynchronous nature of JavaScript to the idea of states, you make it much more tenable to understand what's going on. And I think, you know, those of you working in JavaScript can really appreciate this. So that's what I was talking about. And I want to conclude with, you know, the story, the idea behind the story is basically technology is not created in a vacuum. And I mention this because I think it's important for those of you thinking about innovation and what comes next is what can we learn about how technology arose in the past to try to understand what technology is going to arise in the future. And the web was born from a very specific technological need. It's since moved into a very commercial space, but there's a reason why it existed. And there's a reason why bad tools become popular. And I'm going to say that good tools support good practice. And that's my talk. Hopefully I didn't go too far overside. I think you might be muted, Peter.
Yeah, I was muted. So again, congratulations. It's amazing to see how it developed through years. I have one first question to you.
Sure.
You mentioned that you actually mentioned that PHP is a horrible technology, and at the same time that technology is not created in vacuum. So do you think in our world now, is it easier to create great technology, or is it harder because of the legacy which we have?
No, it's obviously harder because of legacy. I mean, PHP is still widely used, as you know. And I think that even the authors of PHP kind of are horrified about what it's turned into. You're making new languages. It seems like a new language appears every day. It's a hard thing to do, and there's a whole question of adoption. Yeah, good technology and good practices is hard to do, clearly. Otherwise, we would have a lot better languages lying around, and we wouldn't still be using PHP. We still wouldn't be using, well, I'm not a great fan of Java either. Java, the original language, not JavaScript. So it's another example of where it's very hard. On the other hand, things like Swift from Apple is a very good. Apple's done a very good job with Swift, but does require a really clean break. And Swift is only possible because there's a giant company behind it.
Okay, well, that's interesting. Yeah, so maybe giant companies can create better languages, therefore, or maybe it depends also on other factors like.
Well, Apple forces you to sort of use it in some sense, and they go out and promote it. I mean, internal to Google, there must be dozens of internal languages people have developed, sort of as almost like a hobby. But you don't hear about any of them. Microsoft came up with TrueScript, which something as an improvement over JavaScript, for example, and they promote it, but it sits on top of JavaScript. So, on the other hand, technology like Webpack allows you freedom to introduce new technologies like JSX without really imposing on all your clients to get new browsers. So this is at least one route to get to there. Webpack, of course, has its own technological hurdles, right, as we all know. So.
Yeah. Yeah. Also, there is a joke that people on hackathons, when they start, they start usually with configuring Webpack, and in the middle of the hackathon, they finally configure it well. So, so it works for them.
No, I mean, the usual thing to do is you take one of these examples and you start from there. And some of the examples are terrible. So I actually encourage people to actually figure out how to use Webpack and build like a React or Vue app from scratch. Actually make the directories rather than rely on a starter kit.
Awesome. So
Yeah.
great. There is a question from Daniel Janus. Have you ever personally met Tim Berners-Lee?
Tim Berners-Lee, no, because he was at CERN, and I only visited CERN on occasion. I've only been there for a few weeks. I work mostly in other laboratories in high energy physics, which is kind of funny because in terms of high energy physicists, most people spend a lot of time at the CERN laboratory, but I actually didn't myself.
Okay, David. So let's jump to the next point of our program. So you're now invited to visit our Remo platform. There will be a special table with your name on it, and you can. Well, some people from the Warsaw JS community are going to ask you some questions. I posted now this link to anyone who would like to join. Unfortunately, the places at this table are limited. However, this will also create a place where you can really talk and listen to each other. So thank you very much. It was a great honor, David, again to meet you. I will also
my pleasure.
I will also share your website later and maybe slides if you access, and also the whole recording will be published soon on our YouTube with some remake.
All right.
So thank you very much, David, again, and let's welcome. Maybe before we welcome Bartek with the next talk. I will tell you that we expand as Warsaw JS, and we started a new initiative. It's called Warsaw JS Facebook group, and and the Warsaw JS Facebook group is for everyone who wants to learn JavaScript together with others. All you need to do is to join our Facebook and get the link from there, where you can also subscribe to the group. And luckily, we also found out that the Warsaw JS that Facebook actually allows you to use both languages at the same time, because the translations are so good now that it's really fine. So yeah, just join and see if you're interested. So let's welcome now Bartek Bilejczyk from 10 Clouds, one of our sponsors. Bartek, are you here?
Yes, I am.
Awesome.
Yes, I am.
Are you excited? Are you excited that your talk is going to be now?
Yeah, I'm very excited, a little bit stressed, but it's going to be fine.
Awesome. Can you try with your slides?
Yes, sure. Screen 2. All right.
Okay, looks fine. All right, so good luck. You have 25 minutes for this presentation, not longer. So I will interrupt you if it goes too long. So good luck, Bartek.
Okay, thank you very much, Piotr. Hello, everybody. Thank you for having me, of course. It's an honor to present some of my ideas along with David and Guillaume. So that's really cool. So the title of my talk is white labeling your product, right? With SASS and some env variables. And the idea here right now is that imagine that you're making a product that you would like to sell to different clients, right? So it must be a platform that allows the client to have their own branding, to have their own content, to have their own logo, for example, right? But you still want to be like the one that maintains it, that adds new features, so it looks a little bit like SaaS model, right? So you could sell it in a SaaS model. And right now I will show you the example app that I created. It's for Amazon. And this is the app that we're gonna walk through to show you how we can change this layout created for Amazon, for example, for Google or for Facebook, right? So this is what will be covered in this talk. The agenda is the product overview that I already gave you. I will also talk about what won't be covered in this talk, because there may be some you may understand the theming a little bit differently than what's on in the talk. I will also tell you what we need to do step by step in order to achieve this particular thing that we were trying to build, and then we'll go, each step by step to really get deep into it and understand what's going on. And then there are some useful links, so some other approaches as well at the last slide. All right, idea and product overview is already done. What won't be covered in this speech? So the solution that I created is probably not suitable for if you prepare this product for, I don't know, 100 clients or 1,000 clients, right? It probably could be a good foundation, but it would probably also need some adjustments to that. Also, the solution that I created is not something for the user, right? It is something for the client, like the company that you're making the product for. So in this app, there's no possibility to change the colors for yourself. It's something that changes on the build, right? When you push it to deployment, and then it changes for a given client. And also, I made a couple of mocks. Everything is on front end, so probably some integration with backend could be useful in the future to, of course, serve some things dynamically. All right. So what we need to do to actually achieve this result here. So we need definitely like a Vue app or React app or whatever, which I will show you in a second. But in order to achieve this simple and quick changes between, let's say, Amazon and Facebook, we need definitely some color themes, which will tell us more about about the color palette, and also some other variables regarding buttons, regarding paddings, margins, things like that, things that may differ, right? We also need some specific styles, for example, for logo, for buttons, for some components. The app is quite simple, but it could get bigger. I will show you how I created this with some SASS variables, and you will probably understand how to make it bigger. Also, we need to serve images, different images for different clients, such as logo or this illustration here on the right. As you can see, also there's some specific data, right? Specific data regarding products. Of course, Facebook doesn't have Amazon Prime or AWS, so we also need this to be dynamic. I will right now go to the last one. We also need favicons, right? Which here you have this small Amazon favicon at the top, and when we change this to Facebook, it should also change. Yeah. One of the most important things that I struggled with a bit during creating this app is that when you build the app for Amazon, it shouldn't contain any data for of Google, right? Any names, things like that, or from Facebook. And actually, I achieved this, and based on the structure that I will show you in a second, it should work properly. Okay, so walk through now. We'll go to WebStorm to see the general idea about the app, and then I will go step by step with you what I did to actually achieve this. Okay, so source looks normally as Vue or React app, there are some assets inside fonts and some product-specific assets, meaning logo and illustration. There are also some components here. I created base logo, but it could be without it. It could be just an image in app view. There's also some config which has TS files, and here there are all data that tells the app what products should be shown, right? And last but not least, definitely not least, styles, one of the most important folders here that contains some global files that I created, like normalize, some mixins, some functions as well, which are not 100% necessary here, but I created them, and also some variables, which I will talk about in a second. There are two important files also here. So app view should be visible, I think. So app view is the only component, is the only wrapper here, and it contains some of the logic here, right? The template and some of the small logic which image should be shown, and also the products. Okay, so let's take a deep dive right now and start with env local file. So here there is a Vue app dev product environment variable, which currently is set to Amazon, right? That's why you can see this app. Let's quickly change it to something else, just for you to not be bored, to see something that really changes. And let's select Facebook. All right, Vue works quickly, and voila, we have the same code, but it uses a little bit different. It uses a different theming. It uses different data, right? And you can see that it's the same app, but it looks, let's say, totally different. Yeah, okay. So we will use this Vue app dev product and variable in different places to actually achieve what we want. Okay, so first thing will be styles, right? So let's go to styles, global, and yeah, and maybe to Vue config as well. So we would like to import these styles for the whole app, right? That's why we do it here in Vue config, not in main TS, for example. In main TS, we just import some main CSS, but in Vue config JS, we would like to use this loader options and import the styles here. So you can see that there are mixins, there are variables which are some global variables. They can be set like that. I created only box shadows and some measures in 8-pixel design. And functions. And here the 11th line is the most important one. So so as you can see, if we change the end variable, it will take either variables Amazon, variables Facebook, or variables Google, right? Which are almost the same in terms of structure, but they differ because there are different colors, different values for some other keys. Oh, maybe that would be better.
I'm sorry to interrupt you, but because we have a small technical issue, can you please somehow make the size of the font bigger?
Yes, I can. Like that?
Yeah, this is now much more legible. Thank you very much.
Sure. Should I go a little bit, to some other files that I was showing or not?
Yeah, you can show some of them again if it's
okay.
still important for this. Yeah, I think so. Thank you very much.
Not a problem. Okay, so sorry for, I thought that it's visible, but it wasn't. So let's go back a little bit and see app view. So here in view you have the template, right, which contains the, let's say, HTML stuff. There is script, which imports components, and also have this this new view 3 setup in which I compute what the image should be, the illustration, and also which products should be shown. What else? There are also some global variables that I set, meaning the global measures, global box shadows, things like that. It of course may depend on your app, whether this is true for all 3 apps or not. And also the env local file with which I started is that view app dev product is the only env variable right now, and it can be Facebook, Google, or Amazon. All right. Sticking with the styles right now, let's go, because you saw Amazon as the first one. Let's go to Amazon right now, and here there are a couple of SASS variables. So there are colors, and there's a couple of them: primary, accent, some text colors, and the background for. Because the illustrations are a little bit different and have different backgrounds, the background also differs between all the products. There are also some local variables for logo. It is exactly the same here, but it could be different. For example, when logo is not rectangular, or when it has the same width and height, right? And also the buttons are different. I try to make them look almost exactly like on Facebook or Amazon products, but you see the difference probably. And here at the bottom, there's a change for there is a variable for font, and also for the config for font faces, because not every font has a medium font or regular. That's not important right now. And I will also show you Facebook and Google quickly. As you can see, here is Roboto. It's 8 pixels and not 4. There are some differences in button, of course, and the colors, right? So this is what we needed to make the themes for a given company. And if we would like to add another, we just add a new file here and change the environment variable in env local or in env file. All right. So this is what I had for styles, and right now let's go to images, right? Because as you can see, the logo and illustrations differ between all the products. So in assets, I have this product specific folder in which I have 3 additional folders: Amazon, Facebook, and Google. And the illustration for Amazon is this. The illustration for Facebook is a little bit different. And for Google as well, it's a different illustration. And right now, let me show you how it's implemented in AppView. So I use Computed for that. And it returns an image, which is in assets, product specific. Then you use the process env, and you use the view app dev product, right? The variable, and then illustration PNG. One of the problems that I see here, of course, is that some illustrations may be PNG, some of them may be SVG or whatever. This is one of the things that I didn't want to focus on, because it's a caveat, right? It's some sort of it might not be a problem if you have everything in PNG, as I have right now. So this is how logo and illustration differs between products. And let's go right now to JS, how it's set up in JS in config. So there are a couple of files here. There is Axios TS file, in which if you communicate with backend, this is the code that would do the job, right? So you create a new value in headers. I called it here X product origin, and you just set it to the variable, and then you can communicate with backend properly, maybe to serve some data or whatever, right? And in product specific folder, there are three files. I will show you only one right now, because Facebook and Google are the same. And Amazon TS, as you can see, have this config, and it's an object with products that is an array. And I export it as config, and here in app.ts, I require a specific file, right? And during building, this will actually require either Amazon, Facebook, or Google. And then I export it and can use in here in this example in app view. So right now, because we have the end local set to Facebook, app.ts will take this file and take Instagram and Ads Manager, as you can see here, and it will use it. I just import the config here from product specific /app, and I can use it as products, and then iterate through all the products in view. Yes, one of the smaller things that I want to just quickly mention is that all of the products should have different favicons. And here in public folder, in favicon folder, I have three icons for Google, for Facebook, and for Amazon. And they are implemented in index.html. So here is this link for favicon. And the href is a little bit weird. It looks a little bit weird, but as you can see, it uses the same approach, meaning process and view up the product. Okay, let's quickly see what it looks like for Google, just for because you haven't seen that. Good. Okay. So it is still a little bit different than the other two. Of course, the conclusion here would be that this approach is not perfect, right? It is something like a good foundation for creating bigger apps. Like I understand that there are some things that may not work for bigger apps like perfectly, but I think it's a very good start for some smaller apps that you could create even yourself or within your company, that you could sell to different clients, and based on that, of course, earn some more money, right? And have more clients, and a product that is scalable, which is also very important these days. And I think that wraps it up. Again, thank you very much for having me. I will be on Remo in a couple of minutes. And Peter, you can go. We can bring you back.
Thank you very much, Bartek. So
thank you.
Yeah, it's 24 after, so I think that there's not enough time for questions unless someone will ask it now. Is there anyone with a question looking for YouTube? Are you going to share this on GitHub?
Yes, it's shared on GitHub. You probably don't see my screen right now, but I will share. I'm not sure with through which channel I should share it, but it's definitely in my in the presentation in the last slide.
Awesome. Okay, so we'll obviously share your presentation with everything during on the publication we're going to make after we wrap it up into a YouTube video. So,
yes. So for everyone interested, just one last thought. I would like to say thank you to Alex Krasnicki, with whom I work, who also was part of this approach. So thanks to Alex, and thank you for having me. Bye bye.
So we have one last question, please. Tomasz Dmitruk asks, so this approach is pretty cool when you're using standalone product. What if we don't want to sell a complex app, just host it on cloud or something?
I'm not sure what Tomasz means, to be honest. Meaning that you only create for one client, something like that. Maybe Piotr, maybe you understand it differently.
Well, I think he understood that your approach is for a standalone product, but as a complex app would be, like a multi-service approach, like maybe Facebook is a good approach. Would you, for example, if you programmed Facebook from beginning, would you use this approach too?
No, definitely not, because Facebook is just one product, right? So this is actually the thing that I talked about in the beginning. The Facebook, for example, allows you to have this light and dark theme.
Mm-hmm.
I'm selling a service, not a complex app. I'm not sure if I understand this.
Maybe a SASS. Maybe it means a SASS.
Mm-hmm.
Or...
Still, you can configure it, right? If you sell a SaaS, you can still configure it to have some. I don't know how to say that. Some configuration for each client. I'm sorry, Tomasz, if I don't answer your question directly. I'm really trying, but
okay. I'm also not really sure what Tomasz means, so maybe you can explain it better at Remo. So you're welcome again to join Remo, and yes, and thank you very much, Bartek, for this time.
Thank you very much. I will be on Remo shortly. Bye bye.
Awesome. See you. Hey. All right. So now Guillaume from Canada. Guillaume Chevalier, are you here? Can you hear me?
Hello.
Hello, Guillaume. How are you? Do you feel well today? Because I think you recently had a little sleep, or
Yeah, my sleep schedule is kind of offset as well with the distance in Canada here. So, I slept 2 hours. I might stumble in my words, but anyway, let's proceed. And yeah, it'll be I'll be doing fine.
Okay, great. So the next 25 minutes are for you, or 20, depends on you. Just yeah. Let's start, and let's have a short questions and answers session later, and then the remote. So
Perfect.
Thank you, and good luck.
Thanks. So I'm sharing my screen right now. Can you people see my screen? I think in the second screen. All right, perfect. So I will talk about the business process of machine learning. So I work at Neuraxio. I'm actually the founder, and we're doing a lot of machine learning and deep learning projects, processing time series as well as natural language. First, this is not a technical talk, and also this will be super fast-paced because normally this talk takes me 1 hour or more. And now we just have 25 minutes, and it's normally also a paid talk, so I will be doing it for free right now. First, as an introduction, what is AI, ML, DL? So artificial intelligence is a general term that has been introduced in the 1950s, and it's a big umbrella term that contains the machine learning and deep learning. You can think of algorithms that can solve chess automatically, stuff like that. Pathfinding algorithms. Well, it is a very varied set of algorithms where the machine can solve problems. Then there is machine learning, which have appeared more recently in the 80s. And it is then that the algorithms you program start learning some behavior and rules from data to do predictions or to take some actions in the real world. So here you can talk about statistical model being fitted on some data. And most of the time you will see a supervised learning process where you give some examples, training examples to your algorithms, an input and an expected output. And the machine learning model is the mapping between the two, and it learns to predict the good output given the inputs. So you can start seeing artificial neural networks in machine learning algorithms, although there are other machine learning algorithms such as most statistical regressions, such as, for instance, logistic regressions. And finally, there is deep learning, which is much more recent due to unlocking some cool mathematical tricks to allow for deeper neural network. A quick rule of thumb could be that a neural network that has more than 2 layers in depth, layers of stacked neurons, one on top of another. If you have more than 2 layers, then it is considered deep learning. In fact, this is a very cheap rule of thumb. The definition of deep learning is much more subtle than that. But for now, let's proceed with that. So the supervised learning process, how does it work? Well, you have an artificial neural network here in the center, and you present to it some kind of input. It could be an image, some text, sensor readings, things like that. And you want to predict something that might be what is found in the image, what is the sentiment in the text, something like that. In how much time would a consumer buy again this product? What should we recommend? Things like that. So you have an expected target during the training. So you present something, you predict something, and you want to compare the prediction to the target. It is very similar to solving a mathematical textbook exercise where you read the question, calculate and generate the answer, and then correct yourself when you go read what was expected as an answer. And then by comparing what you did to that, you can adjust the weights of the connections between your neurons so that you do not do this error again. So it is about minimizing the error given many training examples. So this is supervised learning. Then this implies a lot of things for a software project. So you will have phases. The first one is to establish a goal, the data analysis and problem analysis. Most of the questions you'll ask yourself that will be important will be in this phase. So is the project even possible? If so, clarify the scope and the goal to solve the good problem. And finally, what will be the prototype that you will program, and what will be the required data format? A problem we often see is that you have a business goal that might differ from the data you have at hand, and you wonder what kind of machine learning algorithm you could apply to the data to solve your business goal, whereas you probably need to do some predictions or to take some actions, and you want to automate this task. So this can be very complex, and it is not to be overlooked, because one of the main failure reason for machine learning projects is having a goal or a problem definition that changes throughout the project, and it is very a good thing to define that properly at the beginning to avoid surprises and avoid restarting from scratch. So afterwards, you have the data acquisition and preparation step of your project. This can take up to 2 months. Sometimes you're lucky and data is already well formatted, but this is often not the case in business projects. And then you do a prototype. So this can take 1 to 3 months on average from what I've seen. And you basically do just the strict minimum to achieve results. Then you do an MVP, a minimum viable product, which is a bit better than the strict minimum prototype in a way that it is functional and it can be showed to people and even sometimes used in an alpha or beta version of your app or project. So you get the prototype to a first usable version. And then you deploy and you iterate on that with some improvements, and this can take up to an infinity amount of time. So you must know what's ahead to succeed a machine learning project. 87% of machine learning projects doesn't go to production. So when you begin the prototyping and the data acquisition and everything, you need to be sure and prepared to commercialize your project. At the end, there are so many things that can go wrong in those kinds of projects if you don't do things properly. The data, the prototype, the licenses, the algorithm, the quantity of data, so many things to consider. So the most important one is the problem definition at the top, as we can see here. So for instance, you may want to program a sentiment classifier. So, okay, you've got your problem, your inputs and your outputs are clear, and you can do a supervised learning on that. For instance, so you have as an input, you have text, and as an output, you have happy, not happy. Now you need a metric to evaluate your model, because you will train a lot of models when working on the problem and training them on the data, and you need to be able to pick automatically the best one. So your scoring metric should be a business metric. And it is noted that this is different than the training loss. It is a metric that is really useful to select the best model. Once you've done this, the problem is well defined, then you can start to acquire and modify and pre-process your data such that the problem can be solved and that the data can be presented to the neural network or the machine learning algorithm. And you can, in parallel, start coding the machine learning algorithms. At Neuraxio, with our clients, most of the time we're doing this part at the right, and our clients are providing data. We can help them format the data in a good way to have the data meet the model at the middle here and solve the problem. So you will train the model on the data and analyze its errors, and depending on what the errors are, you will either work on improving the quality of the data or the model. And at the end, you can deploy to production with real-life data. So establishing a goal. Well, it is about data analysis and problem analysis, as I've said, because the two meets at the middle ultimately to solve the business problem. So machine learning is abstract. It is not obvious. And even having myself 6 to 7 years in the field of machine learning and especially deep learning, I found it hard at the beginning to link algorithms to data set where things meet at the middle. Sometimes it's not clear. It requires a great deal of creativity and also a great knowledge of the existing models and algorithms that can be used, as well as the existing data pre-processing techniques and a good business overview of the problem. So having worked on more than 57 artificial intelligence projects, I realized that someone must have at least, let's say, 4 to 5 years of experience to be able to do those decisions right. So changing goal is very hard once coding has begun. It can be less hard with Neuraxio, which is an open source machine learning framework, and by using proper clean code in your machine learning project. So analyzing things properly at the beginning is important. So as I've said, you want to have a metric in your project to automatically evaluate your machine learning algorithm. So will you have reached your goal with your algorithm? So knowing this automatically is important. It is especially more useful for automated machine learning, also called AutoML. Basically, this is hyperparameter optimization, whereas hyperparameters are like genetic code for your machine learning algorithm. It is like performing a search of the best model, because you can parameterize your models, and you want to take the one with the biggest score. So establishing a business metric, the goal setting phase will help. You want that the algorithm that you pick amongst the one you've coded, or in a way you parameterize the algorithms you've coded, you want this to be done right so that things are really solving your problem. Gathering data. Ideally, you have data, right? Because no data, your project is at risk. It's like half of the project or more. Sometimes it's okay to use public data or someone else's data. In fact, it's most of the time what's done in the industry, coming up with some business deals, checking the licenses of the data. Many things must be considered. And after the first analysis phase, continuing a project without the data is hard. It's really hard to work on the part at the right here without the data, because it is with that you can iterate and improve the whole system. So without the oil in the system, it's hard to make it work properly. So if there's no data, it is required to create synthetic data to be able to advance before the data is obtained. So those projects can be hard, but not impossible. I've seen companies successfully do it without data at first. And data splits. It is a good thing to split the data into train, validation, and test sets or splits. And basically, you train your model with the supervised learning, for instance, process on the training data, and then you use the validation data to pick the best model. And after having done that and selected the best model, you can test it again with the test data and see the score not only in the validation data, but on the test data. And by the way, validation data and test data sets should be from the same statistical distribution. So what you're doing when you're testing like that as well is that you're double checking that you weren't just lucky picking the best validation, the best model at validation. You should obtain similar scores at the validation phase and test phase. Also, validation is sometimes called the development set in other literature. So basically, the training set may be augmented because you want your validation and test splits to represent the real problem you want to solve, and you want to evaluate in a way that is as close to the reality as possible on the business side. So you may increase your variety of training data for making your machine learning model more robust to unseen situations, for instance. It might help the model a great deal sometimes. So typical data set splits, we often see 70% of the data in the train set when there is low data. And in case of big data problems, well, it's a bigger proportion of the data can go to the training due to the central limit theorem here, making less required bigger and bigger testing data. So it's good to work like that. So as you see here, we split the data, train, validation, test. We train the model in it, and we can analyze the bias and variance. This is also referred to as sometimes the underfitting and overfitting. It's not exactly the same thing, but it's quite related. And basically, you're comparing the train, the evaluation metric of the model on the training set and on the validation set, as well as comparing it to expected performance or to human performance. And by seeing the differences in the way the metrics come up with the scoring, then you can decide, should I improve the model or should I improve the data? Because we'll see later, it can give hints on the parts we should work on next. So once everything is fine and that the validation is good, we can measure test performance and deploy to production with real life data. So if there's a difference, then it means we probably have a bug somewhere. So by the way, data influence the choice of the best model a lot. So a rule of thumb is that the more data you have, in general, the better it will be to use a deeper, more complex model rather than a more simple model. So if you have a small amount of data, then you want to use classical machine learning algorithms probably, or maybe even worse, some very simple hard-coded rules of thumbs, which wouldn't even be machine learning anymore. And this is here. So this chart here is for a hard deep learning problem, such as, for instance, speech to text or text to speech, or machine translation. Those are contexts in which your models, your machine learning algorithms performance can be very good with more intelligence and bigger quantities of data. If you were to solve the problem of an addition, let's say 2 + 2 = 4, then you wouldn't need all of these sophisticated algorithms. So those algorithms should not be used for fun on simple problems. It's good for learning, but you don't want to overdo it. You want to pick the simplest model possible that will obtain the best results on your data. So let's say you train a medium neural network on your data, and that you have some quantity of data here. This might be a good fit, but otherwise, if you were doing a deep learning model on a low amount of data, then it would probably fail, overfitting. And on the other way around, if you were to use a less complex algorithm on this medium amount of data, then it would be bad. You might be better off trying a better algorithm. So this is where automated machine learning comes in handy, because you can automatically test different models where you parameterize the number of neurons in your models, the number of layers that are stacked one onto another in depth, and the learning rate and stuff like that. And you can pick the best model according to your problem. And you can also test not only different parameterizations of your model, but also you can test different algorithms and pick the best one. You can even configure the data pre-processing techniques in automated machine learning as such. So if your model is too complex, here far to the right, your error, which is the vertical axis, will be low for the training and high for the validation. This is simple. Well, if your model is really intelligent and it sees some training data, it will be tempted to memorize it perfectly, and it might fail to give predictions on some unseen new data. So much it was intelligent. It memorized the data. And in the other case, that is the perfect case, your model is not too complex, so it will be forced to learn the underlying rules in the data to come up with the lowest possible validation error. And so this is a perfect fit. And the other case is if your model is too simple, you'll do bad on both your training error and your validation error, and your underfitting. So underfitting is to the left here, and overfitting is to the right. This chart is related to this one as well with the curves, whereas here would be overfitting compared to the blue line to the left, and to the right would be overfitting. So the effect of data quantity on error can be quite important as well. So let's say you have a model of a given complexity, then if you have a low quantity of data, your model might do right on the training data. Like, okay, it's not too complicated to memorize just a few training examples, but it will fail to really grasp what's underneath the data and will fail to generalize properly to new data. If you add more data for this model with a given complexity, then you will reach a point where your model is doing a bit worse on every training example because it cannot memorize each of them perfectly. However, your model will have properly generalized the underlying rules hidden under your data set, such as when it sees new data that is not in the training data, but at validation, for instance, or at the test phase, your error will be much lower. So coding a prototype, ultimately, you must face and realize that you must customize the model to the data. It is not as if you need to adapt the data to a model, or it's not if you're shopping for a model, let's say. You need to come up with the good model according to your data and problem. You use the data and metric. So metric is the business goal, and you may need to customize the data pre-processing for the model. But you have your data is most of the time fixed, and you have this, and so you train your models on the data. before the MVP, you might want to re-optimize things for better results and do some reports to show results to clients and investors with the prototype. Then you do a minimum viable product and deploy. Basically, this is an improvement to either the model on the right side or to the data pre-processing to the left side of the methodology chart I've showed before. You will want to retrain the model on the data many times with the automated machine learning loop. So this is not magic. It is basically just a for loop, as I've said, with some randomized genes for your models. So those genes are called hyperparameters, and there's a kind of genetic selection in your model such that you pick the best one, and throughout the loop, when you try models and models and models again with their specific hyperparameters, then you need a next model to try space exploration algorithm to pick the next genes to try. So you have an exploitation versus optimization dilemma here with this algorithm, but it could be as well just random if you don't have the time to code that. Your computer will just run longer before shooting out some good results. So this is automated machine learning. It's not magic, but it greatly helps. So finally, you want to iterate and redeploy. So choosing what to work next. If data is lacking, gather data. If you don't have a good model, code a good model. If you train multiple machine learning algorithms back to back, work on the one that causes the most error first, and briefly focus on the main points. And you guys are working in JS a lot. By the way, 80% of the machine learning ecosystem is in Python. So chances are that your machine learning scientist will work in Python or want to work in Python to go faster. This is changing. More libraries are appearing in JS. But what I recommend for the deployment is either of the two options as follows. So you can use a Python microservice using Neuraxle and also TensorFlow as well. And you might otherwise want to program a TensorFlow model in Python and then export it to disks and load it within TensorFlow.js. But if your team is entirely working in JavaScript and not with Python, you might as well want to be working with JS altogether. But it might be easier to work with Python and connecting to a microservice using your front end with a REST API, for instance. This is what I recommend still. Although it can be really interesting to code browser extensions and some stuff with TensorFlow.js and mobile apps with the model on the device. So finally, there's the data and model quality at equilibrium, and redoing the green and red steps as new data comes is a must. So to conclude, yes, there is also the deployment iterations. So you collect the data, you prepare it, you split the data sets in train, val, test, train the model with the automatic machine learning loop, validate and select the best model, and test the model, deploy it if it works good, and restart with new data as you collect it as you go. Sometimes you don't have this loop, but it's good if you have new data and can retrain your model. And if you need better scores, and if your data drifts over time and changes, which can be significant. So finally, you've achieved that. Your project works. You want to celebrate. And also don't forget to connect with us, guys, at Neuraxio. You can visit our LinkedIn, Facebook, GitHub, YouTube, Twitter, anything. So again, this is me, Guillaume Chevalier, and also Vincent Antaki, whom I've recently hired after choosing amongst more than 150 candidates who applied for this job. So thank you very much for listening to me.
Congratulations, Guillaume. Great presentation. And I have a first question for you.
Yes.
So Gone Drone asks you, so what's a typical number of neurons for a common problem like TTS or image recognition?
I haven't counted exactly the number of neurons, but I do have counted the number of connections between neurons, what we also call parameters. So often models can take millions of parameters as such, or also even more recently, it can be a lot more. And this can easily weigh a few gigabytes when serialized to disks, such as it can be a few hundred megabytes to let's say 16 gigabytes. Sometimes you have really big models when you save them from TensorFlow, and it can vary a great deal. So the more you have data, the more you will probably need a lot of parameters to capture all of the nuances in the data.
Cool. Thanks for this. There is one more question from me. You said you worked on 57 projects on machine learning?
I should specify artificial intelligence projects. Not all of them are machine learning. So,
Okay.
Yeah, I have a really
speaking artificial intelligence. Cool. So I wanted to ask you if you would how could you make the results of these projects better? Where was the bottleneck if you were working on that? Was it the hardware, the software, or mostly your own ideas and approaches how to make this better?
Really good point. As Ray Kurzweil, which is I think the chief innovator at Google, the biggest problem right now is the algorithms. So it is the model. We have the computing power at hand to do all sorts of things, and if not, it's coming soon with Moore's law that still is improving and not completely stagnant. And it is really about finding the good abstractions and ways to connect the neurons together and layers together to get maximal prediction results. So this is for really complex projects. In practice, I've seen that the biggest fail reason are around clean code and poor code quality. So one thing is that machine learning scientists and data scientists should have a lot of skills both in programming and stats, not only one nor the other, nor half and half. So this is why it's a long decision to learn all of this and to be proficient in this. And at the beginning, you might not find easily a good job. Well, it might be the case today, but when I started, it was really not popular. So people wouldn't even know what it was. So I think we have another question.
Yes, so Gondron again asks one last question. What part of ML do you consider of most challenging? Free-form text parsing, NLP, convolutional, or is it all a matter of having good quality data?
Well, having good quality data is always a problem. And otherwise, for instance, free-form text parsing or just free text in a natural way, it will take a lot of computing power to go through that. So I would say convolutional neural networks, especially computer vision, is mostly or kind of like visited and seen. It's been since 2014 and 15 and 16 that computer vision has been quite okay and good, and it's not the most challenging, but the fact that half of the worldwide patents in AI are in computer vision makes me a bit I'm better served in natural language processing projects and time series processing projects to have more freedom, basically, let's say. I think the most challenging right now is NLP. It is where there is progress right now. Text is indeed really complicated. How ideas interweaves together and stuff. Well, natural language processing is the thing right now that is most challenging, I'd say. And yeah, computer vision is a bit solved behind. Now it's not completely solved. There are still lots of things to improve in computer vision and stuff, but computer vision has came to fruition before natural language processing for sure. So in the end, good quality data is always a problem, and I've especially seen clean code to be a problem as well, whereas people code prototypes as research students, not caring about commercialization of their algorithms, and then they face all sorts of legal problems with the GPL license and stuff and other things, and the license of the data, and also the fact that they've just poorly programmed their project in a way that they only generate some results to publish in their paper, but it's not in any way some clean code that can be deployed to production. It often depends on the disks a lot, loading data, pre-processing it, saving it to disk, and reloading it, doing the prediction, saving the prediction to disk. It's not like if the thing was going in and out in production. So lots of challenges here I've seen.
Thank you very much, Guillaume. This actually also answers my question, which of these three is difficult. So the ideas are great, the hardware is also super fast and fine, but the software in between is poor quality, let's say. That's quite funny. So thank you very much, Guillaume. I invite you now to Remo. There is your table with your name on it. So please join Remo and talk to us a bit. You're all guys now invited to join us there because there is enough space and subjects to talk. So please join us, and thank you again, Guillaume, to be your host. And I'm really happy to meet you, to have you here on stage today. So the last thing I wanted to say is that we started this auction, and I want to share my screen so to show you. Okay. Yeah, Warsaw JS chess swag, and there are the tweets where people said that, oh my god, when is the next Warsaw JS? I want one of those. So we made it available. Now it says 42. Possibly the price will be greater. It was greater last time, but it was last time. So one more thing I wanted to say in the end. So thanks for the sponsorship. ThankClouds, Daft Code, FreshUp, ActHelp, Prisma, Sumo Logic, and Xfang. Thank you very much for this. And at the same moment, I also wanted to invite you to our next WarsawJS Meetup. This is going to be on the 10th of February, because it's always on the second Wednesday of the month. So thank you very much again. Thank you for joining us. And yes, and I will also paste you now the link to Remo if you haven't seen it before. So yeah, here you go. There is the link to Remo. So see you soon on Remo. Bye bye.